Today we have an interesting problem. We break a stick at a uniformly chosen random location. Find the probability that the shorter piece is less than 1/5 of the original. Okay, so let's draw our stick. And then by scaling, I can just assume that the stick has length 1. This is kind of a scale invariant process because the location is uniformly chosen at random. So this problem is invariant with respect to the length of the stick. Now, if I divide this stick into 5 equal pieces, okay, then the event where the shorter piece is less than 1/5 of the original is simply going to be if I break the stick anywhere in this region, not including the endpoints, although that doesn't actually matter, or I could break it anywhere over here, okay? So if my breakage point, or actually this endpoint should technically be included. Okay, so if I break the stick at anywhere in this location where I'm between 0 and 1/5, then clearly the shorter piece of the stick is going to be less than length 1/5. And similarly over here, if I break the stick anywhere between 4/5 and 1, then the length of my shorter end is going to be less than 1/5 of the original, okay? So, and then of course, if I break the stick anywhere in here, then the short end of the stick is guaranteed to have a length larger than 1/5 of the original, okay? Now notice that this single point doesn't actually matter because there's a 0% probability that we're going to land perfectly on 1/5. If I throw it, this is a truly an infinite, there's an infinite number of possibilities for where I actually choose to break the stick. In fact, an uncountably infinite. Like for example, I could choose 0.1379256, etc. as my location for breaking the stick. And so any individual point on this line has a 0 probability of being chosen. We're just considering intervals. And intervals have a non-zero probability of being chosen, okay? And in particular, the interval of our consideration has a total length of 2/5. Okay, namely this interval has a length of 1/5 and this interval has a length of 1/5. So the probability the shorter piece is less than 1/5 of the original. This probability is simply the probability that x lies in either 0, 1/5 union with 4/5, 1, where x is the random variable which corresponds to the point that I've chosen on the interval, okay? And since we're doing a uniformly chosen random location, then the probability of landing in an interval is simply the length of that interval, okay? Because I've scaled everything so that the total stick has a length of 1, okay? So every interval has an equal probability, and that probability is going to be proportional to the interval's length. And since I've scaled the problem such that the total interval has a length 1, then in fact the probability will exactly be equal to the length of the interval, okay? And so by results of probability theory, we know that since these two intervals are disjoint, this probability will split as the probability that x is in 0, 1/5 plus the probability that x is in 4/5, 1, as these intervals are disjoint, and then both of these probabilities are 1/5, which correspond to the length of the interval. So this is just 2/5. All right.